नमस्ते दोस्तों, आपका स्वागत है मेरे चैनल पर। इसे सब्सक्राइब करें और घंटी आइकन दबाएं।
Every day of our lives, we witness the same routine. We watch the sun rise, travel overhead, and eventually dip out of sight. For centuries, humans trusted that daily observation. It suggested that the ground beneath our feet was a stationary stage, and the sun was doing all the traveling around us. But our eyes are lying to us. The sun is sitting still relative to our position, while we do all the moving. To understand how day, night, and the seasons work, we have to pull back from our ground-level view and look at the physical geometry of our planet hanging in space. Every daily event we experience in the sky is an optical illusion, created by our own constant motion through the solar system. The first layer of that motion is a constant spin. Earth is rotating on its axis right now, at roughly 1,600 kilometers per hour. Think of the sun like a massive spotlight in a dark room. It doesn't move around the room. Instead, Earth acts like a spinning chair, rotating us into and out of that single beam of light. One complete rotation takes exactly 23 hours, 56 minutes, and 4 seconds. When your side of the globe spins into the solar beam, you experience daytime. Simultaneously, the opposite side of the planet is physically turned away, cast in the Earth's own shadow. What we call a day is simply the measurement of our planet completing one full 360-degree turn inside that fixed spotlight. Many people attribute the shift between summer and winter to Earth's distance from the sun. However, the path of our orbit is nearly circular, and our distance from the sun changes very little throughout the year. Take a look at this diagram. Earth isn't perfectly upright. As it travels its orbit, the planet is permanently leaning on its axis, represented here by this 23.5-degree angled line passing through the poles. This permanent lean dictates where the sun's heat lands. When the Earth is tilted toward the sun, the northern hemisphere, specifically along the Tropic of Cancer, receives direct, concentrated sunlight, producing the high temperatures of summer. 6 months later, Earth reaches the opposite side of its orbit. The planet is still leaning in the same direction, but now the southern hemisphere, along the Tropic of Capricorn, leans directly into the light, bringing summer to places like Australia. The extreme peaks of this tilt are the solstices. On June 21st and December 22nd, the planet leans most dramatically toward or away from the sun, creating the longest and shortest days of the year. Midway between these extremes are the equinoxes in March and September. Here, the Earth is positioned sideways to the sun, allowing solar energy to spread evenly across both hemispheres for spring and autumn. The seasons represent a cycle of solar energy sweeping across the globe, dictated by the fixed lean of our axis as we circle the sun. If you travel to the absolute top or bottom of the globe, the 24-hour cycle of sunrise and sunset ceases to function. Because of that steep 23.5-degree angle, northern regions like Norway and Finland get trapped in the sun's spotlight. During their summer, the sun hovers right on the edge of the water, but never actually sets, resulting in constant daylight for 6 months. When the orbit takes Earth to the other side of the sun, that same angle hides the pole from the incoming light, plunging the entire region into a 6-month freezing night. Anyone standing there wouldn't see the sun rise in the east and set in the west. Instead, it traces a shallow, continuous ring around the sky. These 6-month cycles demonstrate the physical reality of Earth's tilt in its most visible form. If we were oriented vertically, these extremes would vanish. What would it take for humans to artificially pause this cycle and experience a permanent day? You would have to board a jet at the equator right at sunset, point it due west, and fly at exactly 1,670 kilometers per hour. By doing that, you would cancel out Earth's rotational speed, keeping the sun frozen outside your window. But what would happen if the planet itself were to suddenly slam on the brakes and completely stop rotating? The physics would be immediately catastrophic. The atmosphere and everything on the surface would keep moving. Humans, oceans, and buildings would be launched eastward at 1,600 kilometers per hour. If the rotation slowed down gradually instead, we would eventually reach a state called tidal locking. This is what happened to our moon, where its rotation matches its orbit, keeping one side permanently facing the body it circles. On a tidally locked Earth, one hemisphere would be trapped under an eternal, scorching sun, while the other half would freeze in permanent, absolute darkness. The stability of human life, our predictable days, nights, and seasons, depends entirely on the steady, unceasing rotation and orbit of our planet.
Like, comment and subscribe my channel.